In this video, we'll show you how to use the Trace 360 feature of Apple's Trace. After watching, you'll understand how to isolate problems in distributed IT systems using Trace 360's transaction visualization. When a user views a page, the server delivering the page typically connects to other services, which in turn connect to even more services, to gather content for the page. In Apple's Trace, each connection between services is called an operation, and all the operations for the page make up a transaction. Trace 360 traces all aspects of transaction execution, including end-to-end flow, code timing, contextual log, exceptions, and SQL statements. Let's take a look at a sample use case. Jenny is one of the developers of the Advantage banking application. She is currently on call to provide app support if needed. The average server time for the page is displayed, and Jenny clicks the View Slowest Calls button to drill down to see the page's slow calls. By default, the slowest call is displayed, but Jenny can select the slow call she wants to look at. She clicks the View Call List button and views the list of slowest calls. Here she can filter very slow outliers and choose a representative call to investigate. The top part of the page shows the transaction timeline, which lets Jenny see which operation is taking the most time and therefore needs to be investigated further for performance issues. Underneath the timeline, the operations flow tree shows Jenny the relationship between the different operations in the transaction and also lets her drill down to view more details. Each of the transaction's operations is displayed as a bubble. The height of the bubble represents the operation's self-time, which is the time spent specifically on the operation itself, excluding any child operations it may have called. From the height of the bubbles, it is immediately clear to Jenny which operation has a performance issue and is taking more than a minute to complete. By placing the cursor on the bubble, Jenny can see further details, including the operation name, and can also see the operation highlighted in the hierarchical list below. Jenny clicks the bubble to view and investigate the operation's method flow. In the list of methods that is displayed, Jenny sees that the method with the highest self-time is the SQL query, so she clicks on it to see the specific SQL statement issued by the operation. In this case, Jenny sees that it is related to generating database locks. On the timeline, Jenny also notices that there is an exception and views the tooltip to get basic details about it. This shows that there was a timeout exception. Jenny clicks the Exception tab to view more details about the exception. It shows that there was a timeout exception due to slow response. Jenny decides to view the transaction log to see if it contains any entries that may help her further understand the problem. She clicks the Log tab on the left to view all the log messages automatically captured as part of this transaction. Here she can clearly see that the DB lock activity is taking place as part of this transaction. Jenny realizes that a change made to the code yesterday is accidentally causing the database tables to lock, so she decides to roll back the change and within a few minutes sees that the problem has gone away and performance is back to normal. Thanks to Trace 360, Jenny was able to gain a holistic view of the problematic slow transaction, which helped her to quickly isolate and fix the problem and prevent further complaints from customers. For details on working in Apple's Trace, refer to the Apple's Trace help. Thank you for watching.